dados estão chegando. O que está me incomodando é que o vídeo do YouTube está dando problema. Ctrl Shift. É Ctrl Shift P? Aba. Aba nova no anônima no Ctrl Shift N, né? Vamos ver. Ctrl Shift N, né? Pronto.
Está lá, né?
Tá assim.
Então deixa-me enviar rapidamente por e-mail no link, né?
Pronto, só se eu já posso editar isso aqui, ó. Pronto.
Está lá, né?
Tá assim.
Não entendi. Então,
se eu só quiser dar tempo de editar o título, só.
Lá, pode ser.
Pronto, só se eu já posso editar isso aqui, ó. Pronto.
Está lá, né?
Tá assim.
Não entendi. Então,
se eu só quiser dar tempo de editar o título, só.
Lá, pode ser.
Pronto, só se eu já posso editar isso aqui, ó.
Está lá, né?
Tá assim.
Não entendi.
Se eu só quiser dar tempo de editar o título, só.
Tá, né?
Só se eu já posso editar isso aqui, ó.
Está lá, né?
Tá assim.
Não entendi.
Se eu só quiser dar tempo de editar o título, só.
Tá, né?
Se você recorda o título de cabeça, editar isso aqui.
Está lá, né?
Tá assim.
Não entendi.
Se eu só quiser dar tempo de editar o título, só.
Tá, né?
Se você recorda o título de cabeça, editar isso aqui.
Está lá, né?
Tá assim.
Não entendi.
Se eu só quiser dar tempo de editar o título, só. Pronto.
O áudio está saindo no microfone.
Está sendo aqui.
No notebook ou na caixa?
O áudio está sendo notebook.
O áudio está sendo do que a gente estava ouvindo no notebook.
Ah, entendi.
Isso. O senhor se recorda o título?
Deixa-me ver.
Esse texto.
Sim. Posso sair?
E altera a categoria de entretenimento para educação. Isso. Salvar.
E agora meto onde aqui no...
A gente precisa fazer essas alterações aqui. Só editar aí. Isso. E salvar as alterações também.
Agora é só salvar.
Isso. Aí o senhor quer o link para...
Quero o link para enviar por e-mail.
Clica aqui no transmitir agora. No evento que a gente está transmitindo agora. Aí o senhor sobe a página um pouquinho. Clica com o botão direito copiar o URL do vídeo. Isso. É só mandar agora.
Tá, deixa eu ver aqui.
Essa aqui já tem prática.
O negócio não é difícil, o problema é quando dá problema.
Mas geralmente o problema da conexão, da internet.
Geralmente o problema é o YouTube. Geralmente o problema é do YouTube. Que acontece, o problema da câmera também, que às vezes ela não pega o vídeo, tem que ir lá na aplicação editar. Ou então no YouTube é que você inicia a transmissão e ele não carrega nesse tempo.
Fica nesse erro.
Você tem que fechar, iniciar. Por isso que eu uso um outro aplicativo que é streaming do site, justamente
Pra ver se tá funcionando.
Certo. Podemos seguir.
Você só deixa esse daqui aberto. Só pra gente poder acompanhar aqui.
Tá.
Se fosse um retorno.
Certo. Podemos começar então, não é?
Sim.
É?
Tudo certo.
Vontade, tudo certo.
Valeu, velho. Qualquer coisa.
Good afternoon. In a moment, we will start the first conference on statistics and data science, CSDS 2018. For this reason, we kindly ask you to turn off your cell phone. Ladies and gentlemen, this first conference on statistics and data science has been organized by the Department of Statistics of the Federal University of Bahia. The purpose of the conference is to bring together researchers and practitioners from the academy and from the industry to develop and apply statistical and computational methods for data science. This conference will provide an environment to share and discuss ways to improve the access to knowledge and to promote interdisciplinary collaboration. The scientific program will be very appealing for statisticians and data scientists interested in quantitative methods for decision making. It will include plenary talks, invited paper sessions, short courses, roundtables, contributed papers, and contributed posters. Together with the first conference on statistics and data science, 2 other events are being organized. The first LARS IASC School of Computational Statistics and Data Science from November 15 to November 17, and the day of the Maximum Criticism Workshop on November 14. We would like to thank the following sponsors of this event: the Federal University of Bahia, the Institute of Mathematics and Statistics of the Federal University of Bahia, the Department of Statistics of the Federal University of Bahia, the Laboratory of Statistics and Data Science of the Federal University of Bahia, the Regional Statistical Council of the 5th Region, the Brazilian Statistical Association, and the American Statistical Association. We are also grateful to our national and international guests who participate as plenary speakers, short course presenters, speakers at invited sessions, discussants in roundtables, and presenters of contributed papers and contributed posters, and of course, to all participants. To compose the table of the opening ceremony, we invite Professor Evandro dos Santos, Dean of the Institute of Mathematics and Statistics of the Federal University of Bahia. Professor Paulo Canas Rodrigues, Chair of the Scientific Program Committee of the CSDS 2018. Dr. Gustavo Pessotti, Director of the Superintendency of Economic and Social Studies of Bahia. Professor Giovanna Oliveira Silva, Head of the Department of Statistics of the Federal University of Bahia. Professor Lisandra Fábio, Chair of the Lower Organizing Committee of the CSDS 2018. We invite you now to please join us in standing for the playing of our national anthem. Before proceeding, we would like to acknowledge the presence of Mr. Acácio Coutinho, Mayor of Carlos Chagas, Minas Gerais. To welcome you, we will hear from the Dean of the Institute of Mathematics and Statistics of the Federal University of Bahia, Professor Evandro dos Santos, on behalf of his magnificent Rector of the Federal University of Bahia, Professor João Carlos Salles.
Boa tarde a todos e todas, caros colegas de Instituto. Estou aqui hoje para dar as boas-vindas a esse importante evento, a primeira conferência sobre Big Data. Primeira muito bem organizada, apesar de todas as dificuldades. Eu presenciei o esforço dessa equipe de organização. Parabéns desde já. Foi um evento assim, muito bem comentado, inclusive nas redes sociais. Sucesso garantido. Mas duas boas-vindas para esse evento. Esse evento faz parte da comemoração dos 50 anos do Instituto de Matemática e Estatística. Esse ano nós completamos 50 anos e o Departamento de Estatística é parte importante dessa história. E para brilhantar essa belíssima história, está organizando esse belíssimo evento que com certeza terá muitas contribuições para o Departamento, para o Instituto e com certeza para a Universidade. Obrigado pela atenção e bom evento a todos.
And now, I'll work over to the chair of the Scientific Program Committee of the First Conference on Statistics and Data Science, Professor Paulo Canas Rodrigues.
Good afternoon to everyone. On behalf of the Scientific Program Committee, I would like to welcome you to Salvador. This is the first conference on statistics and data science, and where we have the pleasure of organizing it in this beautiful city of Salvador. The organization of this meeting has been carried out by the Department of Statistics of the Federal University of Bahia, and its purpose is to bring together researchers and practitioners from academia and from industry that develop and apply statistical and computational methods for data science. This conference will provide a forum to share and to discuss ways to improve the access to knowledge and to promote interdisciplinary collaborations. The scientific program for this meeting includes 3 keynote speakers, includes 5 short courses, and it includes 4 invite paper sessions, 3 round tables, several contributed papers and contributed posters. So we have a total of more than 60 contributions in total. The aim of this meeting is to offer opportunities to meet each other. I think this is one of the most important things, is that we go home with some new contacts and to share professional experiences. This meeting will cover many of the research areas in statistics and data science. For students and young statisticians, we also have an award for best poster, an award for best paper, and the result will be disclosed in the closing ceremony of this meeting. We also have some social events. In particular, tonight we'll have a dinner right after the round table. We have a dinner, so we have a bus that will leave at 7:30, 7:45, and it will be a dinner with some very nice local food and some cultural show. It will be in Pelourinho, which is the downtown, the old city. So we would like to thank the sponsors for this meeting. So we didn't have any sponsor from the national funding agencies. So I'd like first to thank the Federal University of Bahia, in particular to the Institute of Mathematics and Statistics and Professor Evandro, which gave us a huge help to cover some of our expenses. Also, would like to thank the Brazilian Statistical Association, the CONF 5, and the American Statistical Association for the financial support that they provide us. Last but not least, I'd like to thank all the speakers, all the discussants, all the poster and contribute talker presenters, and all participants for being here with us. Thank you all for coming, and we wish you a good and enjoyable stay here in Salvador. So thank you for coming.
And now, a word over to the Director of the Superintendency of Economic and Social Studies of Bahia, Dr. Gustavo Pessotti, on behalf of his Honorable Governor of the State of Bahia, Dr. Rui Costa.
Boa tarde a todos aqui presentes. Gostaria de saudar o professor Paulo Canes, a quem eu saúdo todos os componentes da mesa. Peço perdão a vocês por falar em português, meu inglês é muito ruim. Eu entendo bem, mas tenho uma dificuldade de pronunciar. Mas queria realmente parabenizar a todos o Departamento de Matemática e Estatística da Universidade Federal da Bahia por essa iniciativa importantíssima, né, trabalhar um tema de altíssima relevância. O professor Paulo me dizia há pouco que esse tema, né, já faz parte de uma pós-graduação, uma especialização, uma das únicas do Brasil com a temática, e trabalhar com estatística e base de dados é de suma importância para o processo de planejamento, para o processo de elaboração de políticas públicas. O convite foi feito ao governador do estado, Rui Costa, que em viagem a Israel repassou o convite para a Superintendência de Estudos Econômicos e Sociais da Bahia. Alguém aqui da plateia sabe, já ouviu falar na Superintendência de Estudos Econômicos e Sociais da Bahia? Levanta a mão, por favor. Poucas pessoas, né? Eu estava pensando como seria a minha abordagem, claro, rápida, por sinal, nessa mesa importante, e eu pensei que, assim, destacar o tema é algo que o palestrante vai fazer com propriedade, e é óbvio que, assim, com o passar, com a evolução, com essas transformações em tecnologia, comunicação, esse tema assume uma importância estratégica vital para o país, para o Estado. E, evidentemente, esse não é o foco do que eu queria falar. O foco do que eu queria rapidamente falar com vocês nesses 2 minutos é que a gente vai enfrentar uma situação, a gente já está enfrentando uma situação extremamente delicada no país, de muitas incertezas, de algumas certezas já colocadas, entre elas esse sucateamento que a gente tem vivido nas universidades, que vai piorar muito, né? O sinal vermelho já foi acionado, já foi evidenciado, que esse sucateamento, que o Estado está sendo convidado a, digamos assim, a se retirar completamente das ações de desenvolvimento do país, sendo acusado de ser o grande causador dos problemas, da inflação, do baixo crescimento econômico, né? E esse sinal vermelho ligado sobre as universidades não é o único dos nossos problemas. Em recente entrevista em rede nacional, o nosso futuro presidente ameaça de forma velada o sistema estatístico nacional, afirmando que, se necessário for, irá até o IBGE e mandará mudar a metodologia para que o IBGE meça melhor a taxa de desemprego do país. É como se o desemprego pudesse ser modificado simplesmente a um simples apertar de botão. Então, vejo com muita apreensão o atual momento pelo qual passam as instituições federais, as instituições públicas e o Sistema Estatístico Nacional. O IBGE é um dos órgãos de maior relevância, não só no Brasil, mas de importância no sistema estatístico internacional. Um órgão de grande respeito, de grande responsabilidade, com técnicos muito compromissados com o desenvolvimento de metodologias, de bases estatísticas, assim como nós na SEI fazemos a nossa parte, né, com as estatísticas públicas, fornecendo dados para análise, avaliação, monitoramento e acompanhamento de políticas públicas. E eu acho que para enfrentar esse momento a gente só tem uma saída, que é o fortalecimento institucional. E eu acho que é um bom momento para deixar claro que a SEI está inteiramente à disposição do Instituto de Matemática e Estatística da UFBA, assim como nós estabelecemos várias parcerias com vários órgãos de pesquisa estatística. Nós compomos o Sistema Nacional de Estatística, nós somos parte integrante da Associação Nacional dos Institutos de Pesquisa e Estatística do Brasil, e eu acho que é importantíssimo que a gente estreite ainda mais as relações com a universidade. É preciso que a gente estabeleça parcerias, trabalhos conjuntos, porque o fortalecimento institucional é necessário para a gente enfrentar esse momento tão difícil. Então eram rápidas palavras, era o sentido mais de parabenizar a Universidade Federal pela brilhante iniciativa, dizer que a gente está no governo muito feliz com essa iniciativa e inteiramente à disposição de vocês para parcerias e para esse fortalecimento institucional. Muito obrigado.
And now, I'll word over to the head of the Department of Statistics of the Federal University of Bahia, Professor Giovana Oliveira Silva.
Boa tarde a todos, né? Saúdo a mesa e a todos os presentes e quero desejar a todos um bom evento, né? Um bom aprendizado, mas também um bom convívio, né? Com as pessoas, com o ambiente, já que a Bahia proporciona um pouco isso, né? Tem um astral um pouco diferente à cidade. E agradecer, né, em nome do Departamento de Estatística, todo o trabalho desempenhado pela comissão, né? A gente sabe o quanto que é difícil, em tempos difíceis, o quanto que é difícil organizar um evento. Então, nosso muito obrigado pelo empenho. De maneira especial, além da comissão, gostaria de agradecer também ao Instituto de Matemática e Estatística, não só na pessoa, né, do professor Evandro, mas também dos funcionários, que toda vez que a gente tem um evento, eles muito se dedicam para que as coisas aconteçam, né? A gente sabe o quanto que é difícil, às vezes, fazer coisas simples, né? Que é comprar uma passagem, né? Reservar um hotel, o quanto que é difícil, às vezes, a gente fazer isso com dinheiro público, né? Quanto que é difícil a gente conseguir realizar os eventos quando a gente depende, às vezes, do dinheiro da universidade. Às vezes a gente tem um dinheiro e não consegue gastar. Então, nosso muito obrigada, né, em nome do departamento, a todos que se empenharam na realização do evento. E, de novo, desejo a vocês um bom evento, que seja muito proveitoso para todos.
Now, a word over to the chair of the local organizing committee of the first conference on statistics and data science, Professor Lisandra Pablo.
Good afternoon. On the behalf of the local organizing committee, I would like to welcome all of you to Salvador, to the Federal University of Bahia, and to first conference on statistics and data science. We expect that this meeting will provide the exchange of knowledge between all of us, and that presents an advance in statistics and data science locally, internationally, and internationally. Locally, we have an extra motivation to organize this conference because our Department of Statistics has recently opened a specialization in data science and big data, which filled in all its 35 vacancies with a long wait list. The second class is expected to start in September of 2020 19. Nationally and internationally, there has been a general movement on the statistical community towards the needs of data science, both in terms of research and education. More discussion these topics will take place in the roundtables of this conference. In the last few months, we have been working hard to provide you with a great scientific program that includes 3 great keynote speakers, 5 short courses, 3 roundtables, invited papers, contributed papers, and contributed posters. You will also have the chance to enjoy the cuisine and the culture of Salvador and of Bahia in tonight's dinner. For those who have registered, the bus will depart from here at 7:45 p.m. I hope you enjoy the conference in Salvador. If you have any question or need any help, please contact me or the members of your team. Thank you all for coming and welcome to Salvador.
At this moment, we are concluding this opening session. We are grateful to the members of the table who are now going back to the plenary. Now, we invite you to the opening keynote lecture by Professor Katherine Ensor, current Vice President of the American Statistical Association. In order to share this session, we invite Professor Paulo Canas Rodrigues.
So good afternoon again to all of you. It is my greatest possible pleasure to introduce you Katherine Ensor. Katherine, she is the Noah Harding Professor of Statistics in the George Brown School of Engineering at Rice University, where she serves as Director of the Center for Computational Finance and Economic Systems. She served as chair of the Department of Statistics from 1999 to 2013, so for 14 years. Yeah, you liked it, right? Dr. Ensor is an expert in many areas of modern statistics, develops an innovative statistical techniques to answer important questions in science, engineering, and business, with specific focus on environment, energy, and finances. She is an elected fellow of the American Statistical Association, the American Association for Advances of Science, and she has been recognized for her leadership, scholarship, and mentoring. She is currently the Vice President of the American Statistical Association and a member of the National Academy's Committee on Applied and Theoretical Statistics. She holds a BSc and a MSc in Mathematics from the Arkansas State University, and she holds a PhD in Statistics from Texas A&M University. Katherine, it is really a great pleasure for me to have you here and for all of us, so welcome.
Thank you. What a great honor to be here. And when I was headed this way, everyone kept saying, it's summer, and I'm like, I live in Houston. So it's the same. So our weather is the same. I think probably the genealogy of our people is the same. And this is my third visit to Brazil. Each time it's just wonderful. So thank you so much for this kind invitation. Get my slides up here. Go to the first. Can you hear me okay? Does this work? Okay. And I apologize for not being able to speak Portuguese. I can't quite keep up. Houston is a very international city. In fact, the high school that my children went to, there were 92 languages spoken in the homes of the students there. So we live in a very multicultural community, but I did try learning Spanish really hard, but even then it's not really very good. I am, again, want to thank you. And so I am a Vice President of the American Statistical Association and a Professor of Statistics at Rice University, where I've spent pretty much my entire career. I like warm weather, actually. So this is a kind of a weaving of different stories, but it's very much a data science and statistics story. And I hope that you will agree at the end that we've kind of woven a nice story together. But I put this slide together when I was giving talks as early as 2009. And I just leave it because it's just such a strong reminder of this last decade that we've lived through. So this was a New York Times article, August 6, 2009, when Steve Lohr said, just for today's graduate, just one word, statistics. Okay, that was before the word data science came into play, but synonymous in my view, although data science incorporates a little bit more, stretches our boundaries, we're all kind of trying to solve the same kinds of problems. And again, Hal Berrien, along the same lines, just said, I keep saying that the sexy job in the next 10 years will be statisticians, and he wasn't kidding. So we really have seen an explosion in statistics and data science in the last decade. We've all lived through it. And it's changed a little bit what we do and how we do it. But I like to always bring this back. So my dad was a chemist, and a diehard chemist. What is there? There's chemists. He's often used the phrase, well, I need to use statistics, and I didn't do my experiment right. so he was a really serious chemist. But he's always challenging me on statistics and where we're going, so this article out of MIT Technology Review is just a reminder to me that what we do is extremely valuable, but it's very valuable beyond marketing and business, which is where it gets picked up a lot. But the lead title on this article, so this is one of our astronauts from way back when, and it says, "You promised me Mars colonies, instead I got Facebook." And so the premise of the article was, all of this great technology, are we putting it toward advancing science? Or are we putting it toward things that maybe aren't quite as important? So at Rice, when we did our, Rice just invested $50 million in data science infrastructure, and so that translates to hiring a bunch of people. And so we put together a committee across the whole university trying to plug data scientists into departments across the entire university. And we came up with this phrase, data-enabled science. So we hired physicists, we hired ecologists, we hired social scientists, and of course we hired computer scientists, statisticians, and electrical engineers, which form the core of data science in our university. And applied mathematicians, I should not leave that off. But the point is that we are able to make significant advances across many, many, many different fields. I really, when we interviewed the physicists that worked in dark matter, my mind was just stretching to try to understand what he was doing. But at the core of what he was doing was a random forest. So that was, peel away all the big pieces. At the nuts and bolts of what he was doing was a random forest algorithm. Well, we can do better than random forest nowadays, right? So we have better tools in our toolkit. So the opportunity to bring him in and have him collaborate with machine learners and statisticians and the likes, really, who knows what will come from that. Okay, so at ASA took a concerted effort to try to incorporate data science more broadly into the society. And so around 3 areas, so education initiatives, communities and publications, conferences, and then we also had this logo, ASA Data Science. And so the idea of ASA, the American Statistical Association, is that it's a big tent and it's a home for all of us that pursue quantitative answers through data. It's a 19,000 member organization, and even though it's called American Statistical Association, it's really a global entity, as probably many of you are members as well. But there is a statement that we released about the role of data science, and it was basically recognizing that statistics is core to the data science field. That without statisticians, you're just going to be reinventing everything that we've learned over the last 100 years. But it's not just statistics. There's also computer science. How do we learn to deal with larger and larger amounts of data? How do we learn to do that more quickly? And then I always say, not too many other people say, that at Rice, electrical engineering is central to this message as well. But we all, we're lucky at Rice because we're all sitting in the same building. So in our building, we have applied math, statistics, electrical engineering, and computer science. So you could call that the building of data science. So it's a wonderful place to sort of hang out, I guess. So some of the activities that ASA has underway. So there's a data visualization poster competition for grades K through 12. So let's get those young kids involved. There's the ASA Data Fest, which is a 48-hour competition of undergraduates to sort of answer a specific problem, and these go on all over the U.S. There's the Fall Data Challenge. This is Statistics Fall Data Challenge. And then at JSM, there's the Data Expo. I always like the Data Expo at JSM. It's sort of how can you create these really nice posters out of data. Okay, and just as importantly are the conferences. So the Conference on Statistical Practice, so that's a relatively new conference for ASA, but it's held every February. This year in New Orleans, so if you haven't thought about going, you should think about going this time. New Orleans is a great city to visit. It's either right before or right after Mardi Gras, I'm not sure. So, and then also the Symposium on Data Science and Statistics. The Symposium on Data Science and Statistics will be in its 3rd year this upcoming year. And it was a reformation of the interface, which was a 40-year collaboration between statistics and computer science. And so the American Statistical Association has taken that on as one of their key conferences. So it sort of ups the game a little bit in terms of organization. But the Interface Foundation still maintains putting the program together for that. And then another new conference is the Women in Statistics and Data Science. So I just attended that for the first time in October. It was fabulous. Sorry, all you men, you're welcome to attend, but it's mostly women. So it was really kind of a nice get together so that we can have some shared experiences and men are welcome at the conference. It's just the majority women. Okay. But it is a nice get together, and I highly recommend it. Okay, so communities and publications. So how do we get the word out? So we do have a new some standing and then a new interest group. So we have the statistical computing section, statistical graphics, statistical learning, and data science. So these have been around for a while. I don't know about you, but I'm a member of all three. And now there's a new interest group on quantum computing and statistics and machine learning. And so that's, again, this larger community. And so a lot of overlap between these, but the goal is to provide a home for those of us that are thinking of the larger data science questions. So there is a journal, Statistical Analysis and Data Mining. So this is the ASA Data Science Journal, and it covers topics including problems involving massive and complex data sets, solutions using innovative data mining algorithms, and our novel statistical approaches, and the objective evaluation of analysis and solutions. And then one of the journals that my colleague David Scott was instrumental in starting, the Journal of Computational and Graphical Statistics. And so this is a long-standing journal that really is a data science journal. As chair of statistics at Rice, I have two claims to fame. One, I hired Ginevra Allen, who's doing really well, but the other is I hired Hadley Wickham. So he was my, he started at Rice and stayed with us until our studio pulled him away, which I think as a global community, we're actually kind of glad that they did, right? Because he was doing fabulous as a professor, but the academic world just wasn't big enough for him, and he just has done so well with our studio, and I, for one, am very thankful. So Garrett Groman, who works with him, is a graduate from our program. So we're very much a data science statistics program. All right, so now on to my example of data science, and okay, walk a little bit. Try this side of the room for a second. Okay, so urban analytics, how many of you like that word, that phrase? All right, so I've been deep in this phrase for a couple of years. And so the idea is data science for stronger cities and communities. Okay, so that just looks like a river, right? Does it look like a river? That's Houston. That's a street in Houston after Hurricane Harvey, or during Hurricane Harvey. Okay. So I'm going to tell the story around Hurricane Harvey because I think it's a great platform for saying how data science can help in real time, help the people that live, help us. Okay, so it's a real-time story for data scientists. This is a horrible graph that I borrowed it from a collaborator, but the point is that it's not just about people, homes, etc. It's also about money. Now, I care about people and homes, but sometimes governments care about money. So this is staggering cost for these recurring losses from these hurricanes. And I mean, we're in the billions and billions of dollars. So now I was lucky, this is my backyard, it's my dog. But this river behind my yard, usually it's not there. And that's a 40-foot deep, usually empty canal that's made to hold water. So I live in a county, so in the U.S. we have counties that manage our utilities and services. And so my county is very well managed. Okay. Now, the fact that the water, so this is a sidewalk that comes right up to my yard. And if it gets in my yard, I probably have another foot before it gets in my house. But all of this water stayed there because the pumps worked. So there were pumps that were moving the water the way they wanted the water to go. So one pump failure in my house is 4 feet underwater. So it does get personal. So what I want to talk about, I want to talk about 4 things. I'm conscious of the time, so it's going to be little, just touching each one a little bit. So the Urban Data Platform, land cover change for 21 years, Hurricane Harvey registry, and the most important thing is the changing rainfall patterns and flood maps. Okay, so the Kinder Urban Data Platform. So this is an effort that I've been pursuing with Dr. Rudy Guerra for the last couple of years. And it's basically a public online data set. You think, well, why is a statistician do this? Well, at the core of what we do is data. And so this is a secure data platform where we can put private data on there. But it also is just a way to collect all possible data about the Houston area. And so it's publicly available. I don't know if you can see the advertisement down there. It's kinderudp.org. And you can register and download data, any data that you want. The private data you can't download, but you can register and go through approval processes and have access to this data. So the goal is to just continue to collect all kinds of data about Houston. Now, many of our municipalities have open data projects underway, but what we find is that as governments change, at the city level in the US, as mayors change, support for those projects goes up and down. So this is a permanent archive of the data for Houston. Okay? And I mean permanent. So we are giving each data set a digital object identifier so that it can be referenced and cited just like a paper. So how did that serve us during Hurricane Harvey? Well, in addition to all the water, is all the huge environmental disaster. And so, I'm deep into the environmental community in Houston, and so instantly have like 20 people that are going off and taking samples. And so we use the Urban Data Platform as a place to coalesce all this data. And so this is the E. coli measurements that were taken. So this is deep in the heart of the city here. And so it's kind of important, right? And this is publicly available. Anybody can download it and work with it. So this map appeared in the New York Times because it wasn't good to have E. coli running through our city. Okay, so this is just an example of the data catalog, and you can do a search on Harvey and immediately get this type of thing. So we're seeing lots of these types of data organization efforts come on. We spend a lot of time designing what we're doing and happy to share any of the technology if anybody's interested in replicating what we've done. Okay, so the second thing is, so this is very much a data science project, and it was underway for a couple of years with a postdoc that's working with me. And he's an ecologist, actually. And so this is looking at the land cover change for Houston. So we're roughly starting with 62 billion raw data values. Now that's not really big, but it is a little bigger than Excel can handle. It's definitely stretches R to its limits a little bit if we're not strategic about how we do it. But the goal is to take all of this satellite imagery over a 21-year period, stitch it together in a meaningful way, and then come up with a movie of how land cover changes in Houston. And these maps are available on the Urban Data Platform. So anybody that wanted to work with land cover in Houston now has this data available to them. So this is just an example of the satellites that we're using, going from 97 up to 2017. And these are details about the different satellites. I won't go into that. But this is an example of how well we're doing. So this is purely data science. Okay, so data in, classification out. So our classification is this picture, and a picture is this. This is one of our ground truthing photos. So what do you think? You think we're doing pretty well? Thumbs up? Yeah, we're actually doing really well. It's 92% accuracy. I mean, it's just amazingly well. But what we do is just a series of spatial temporal filters. There's a Gaussian smoother in there. There's, I would call it more of a library type machine learning effort where certain patterns we choose from a library of patterns for our classification. And those library of patterns are informed by the ecologist. So it's very much a joint effort. And so when we put that together this is actually zeroed in on Houston. This isn't the entire area that we've done. But the red is developed area. So that's 21 years. So what do you think about Houston? Has it grown dramatically in 21 years? Yeah, it definitely has. And what's most important is this region out here. So these are wetlands. What do wetlands do from a water perspective? Like a sponge, right? But when wetlands become concrete, they're no longer sponges. Okay? And so all of this water goes to downtown Houston. Okay, so that's one of our challenges. But these maps really, I mean, no one understood the depth of the expansion until the presented this way. Okay, another piece. So one of the things that we quickly did after the hurricane is my provost. So you quickly get off board, right? She's an environmental epidemiologist, and so together a team of us started a registry for the impact of Hurricane Harvey. Now, why could we do that? Because we have good inroads to all the health departments, we have good inroads to all the city government, and we have the urban data platform that we had previously built. So we have a home for this registry. And I'll skip over this a little bit. And then the next piece, so we're to the fourth one. So those first three went by pretty quick. Are you good? All right, so this one I'll go into a little bit more in detail. So Rice, recognizing that we wanted to engage with the community, they gave each, like 10 faculty members, just a small amount of money, basically enough to hire a graduate student to help you, and to work on a project related to helping Houston recover. And so the project that I proposed was to look at the changing precipitation patterns across the greater Houston area. And this project was brought to me by civil engineers that work on flooding in Houston. Okay, so through the urban development, through, well, I'm not supposed to say it, through the changing climate, I won't say climate change, I'll say changing climate. So does that make it feel better, changing climate? Doesn't make it feel better to me. But, we definitely have increased storm activity and increased flooding in Houston. There's just no doubt about that. And so the message that us in the community are putting forward is learning to live with water. You know, Amsterdam has learned to live with water. Houston can learn to live with water. But to say that the water isn't going to be there is just not practical. Okay, so we have, so we were asked to answer two questions. Have extreme precipitation trends shifted over the past century, and how are these changes related spatially? So those are very statistical questions, right? So we've now got this very complex problem down to key statistical questions. And the resources to answer these questions were gauge measured rainfall. So not radar, not our neighbors, but the government gauges for the rainfall. Okay, so we have about 600 rain gauge stations, and the earliest date goes back to 1870. And so, so they're sort of all over the region here. And here, if I just focus on the gauges that are in Harris County, which is the county where Houston sits, these are all the rain observations that we observed over that 100-year period. Okay, so these are our design points for the city. These are the 100-year flood levels.
Why is there way up?
Okay, so these are different gauges, and each of the three segments is a different watershed. So remember that we're working with hydrologists, and so Houston has 21 different watersheds covering its area, and so our goal is to get estimates within a watershed across all the watersheds. So each line, so this is one gauge, the history of one gauge, and it's just the amount of rain that was observed. And it's all the observations over an inch. Is that clear? Okay, so the purple lines are the 100-year floodplain. So what do we mean by that? Those are the design levels for all the buildings, for all the roads, for all the city infrastructure. That we say, you know, the chance of it flooding at this level or higher is only 1%. Okay, so I have 100 years of data represented up here. How many lines past 1% should I expect to see? Maybe 1, 2? I mean, it's an expectation, right? It's number of years times probability of 1 over 100. Okay, so 100 times 1 over 100 would give me 1. Do I see 1? Okay, and how large are those values? So they're really bumping out here. So this is like 20 inches of rain. And so because of the, whenever Houston has trouble, we always say, Houston, we have a problem. Yes. Go back to our moon exploration days. You know, Houston, we have a problem. So we do have a problem. And that is our problem. So the problem, you know, we can't change this. This is nature. What we can change are these purple lines, basically. All right, so let me go back a second. So here is the floodplains as they stand, and they're basically 7% off the mark in Harris County. And this is from a paper by Hellgate in 2013. Again, these are my hydrologist collaborators. I really don't know this work that well, but the claim is that global coastal flooding is expected to reach 1 trillion per year by 2050. That's the expenditures on flooding that globally we're all going to spend. And in the U.S., Houston is leading that number. So I wouldn't say Houston, we have a problem. I would say world, we have a problem. So it's something that you all have flooding here. All right, so you can all right, so here is taking one Hobby Airport. If you're going to study extremes for Houston, pick Hobby Airport because it's the best data set and everybody around the world studies it. But it is a really good set of data and it goes back to like 1890 or something. Okay, so these are all the observations. We started in 1939 for this. And so these are all the observations at this one location near Hobby Airport, which is our smaller airport in Houston. And here are the output from Hurricane Harvey. Okay, so would you think Hurricane Harvey is in line with what's gone on? It's kind of extreme. But what's also important is notice that it's 3 consecutive days at a very high level. So it wasn't that one day was bad, it was that we had 3 consecutive days of very high levels of rain. Okay, so what I'm doing, I'm not inventing new methods, I'm tweaking them a little bit, but I really am standing on the shoulders of giants in our profession. And I claim that I'm able to do that because I'm well trained as a statistician and data scientist, so that I can jump into a different field. I know the experts, I know what papers to read. And so that's what we do. So modeling extremes is extreme. It's not an easy task to do. And ultimately, this is the end of the distribution that we care about. And so the shape or the distribution that we choose is critical. So this is one location using what's called the extreme GPD fit, generalized Pareto distribution. And it looks pretty good. Would you be happy with that? Those of you that like quantile plots, do you like quantile plots? What am I looking for here? I'm looking for a straight line. Huh? What do you think? Pretty good? Pretty good for extreme value. So it's actually really good for extreme value. Okay, but let me take that same model and go to Hobby. What do you think there? Yeah. So I'm really missing the mark here. so we're underestimating the probability of Harvey with this type of modeling. And so we're doing every possible model we can that exists, and then we'll do a comparison. But right now, what we're finding works the best is this peak over threshold idea, where roughly we model with a generalized Pareto distribution all the values greater than 1 inch of rain. Okay, so our takeaway here is that peak over threshold provides a better fit. It's more robust over all of our 600 rainfall locations. Okay, so then what we did is we took that model and we just did a 40-year moving window. And some of the estimates aren't very good because maybe we don't have enough rainfall in 40 years. But that's okay because I'm gonna keep doing it, right? So every year I move a year. And so the question is, are there trends in this data? So I plotted the 25, 100, and 500 year return periods. What do you think? You think Houston has a problem? Okay, so this is for Hobby, for that data, that one location that I said was really good. Okay, so this isn't really any inference, although we could, if we argue that these return level estimates themselves are random variables, then I could do secondary statistics on this. And at the hydrology perspective, we probably will do some of that because that goes over well in their community. But look at what's important. This 100-year return level is 18.5, where the 13.5 is the 25-year return level. All right, so we settled on our modeling design of this generalized Pareto distribution, 1 inch over peak over threshold model. For those, I think you have a short course at the end of the week, so you'll dig into this a little bit. So I'm preparing you for the short course. But those are enough words that you can go back and repeat our analysis because just Google R peak over threshold and you'll instantly have the software to do this. And so then we're going to apply this to our entire data history and to all of our locations. And so this is what we see. This is the 100-year return period. So this is all of our locations that had a complete profile or semi-complete profile from 1939 to 2000. I think we went ahead and grabbed 2018 for this. And I don't think we did. This would have to be 2017. And so this is the trend line for the 100-year return. And I've highlighted Hobby, the one location where I looked at a minute ago. But these are for all of the measurements. So what do you think? Do you think there's a general increase? The purple line, so if you just follow one of them, it's kind of a messy plot. But if I just follow one of the lines, maybe this one, that's one location. So each line represents a location. And I've done that 40-year moving window, peak over threshold model within each window to estimate my return period, and I've just plotted the return period. Yeah, is that clear? Okay, now why did we do this? Why did we choose this method of analysis rather than some spatial temporal complex model? Well, my hydrologist friend, when we started to collaborate, we collaborated together for 20 plus years. His first words out of his mouth, Kathy, I don't want you to do any of that fancy-dancy modeling stuff. He has a sensitivity. He needs to be able to understand. They understand generalized Pareto distributions. They understand peak over threshold. They could understand the extended generalized Pareto. When I start doing spatial temporal mixing, it might be a little bit complicated for them. But there's also another reason, there's a scientific reason. And that's because our time series at each location are highly variable in observations. So maybe we'll have 5 years, we take a break for 10 years, and then we have 30 years of data. So in time, our data is very, very regular. So if I can focus in on those monitors where I have good temporal information, and then I'll incorporate that into the spatial setting in just a second. Okay, so what we do is we basically are spatially interpolating or spatially modeling our estimates of the 100-year flood period. Okay, so all of our temporal information is rolled up into our peak over threshold modeling, the 40-year window, and then so those become our new estimates. Those become our new random variables. And then we will model those in a hierarchical Bayesian fashion to get our spatial structure. Okay, and we're not ready to release this yet, which is why we haven't published the paper, because we're still refining this. But we did just read a recent paper by Dan Cooley, who did the same thing for the Colorado region. So, great minds. I'll put he's a great mind. But I felt encouraged because I saw this paper by him that this methodology, someone else thought this was also effective. Okay, so we see, again, focusing in on Houston, we see that the high levels are expected right around the region. All the dots are where we have monitors. We have data at every location. And then for the 2-day 100-year flood, we see that it's even greater. I think that this is too smooth, and so ultimately we need to pull out the watershed information a little bit more strongly, which is what we're doing in the next stage. Okay, but with that, so here you can't really see it, but each color represents a different watershed. And so the important piece is to get the estimates within a watershed correctly, because we're not going to tell the insurance companies where the 100-year floodplain is. We're going to feed estimates of our modeling into a physical model of how floods work, given the rain that comes in. Okay, but what we're able to do is we're able to obtain new estimates for our 100-year floodplain. So here's the old design levels, and here are our new estimates, which are consistent with our data. They're a little high. We're still looking into that. And then the stars represent sort of the average return level within a watershed. So what do you think? Do you think we need a new design criteria in Houston? We probably need our houses raised a little bit, our buildings raised, maybe our streets lower. That's what they're doing. Our streets become canals, which means you do have to shelter in place, unless you have a kayak or something. I did think about it. That looked like fun, that little river behind my, until I saw the E. coli numbers. I sort of hesitated. Okay, so in fact, this plot actually went into policy because there was a vote by our city council on building standards. And so this information did inform policy for the region, and the design criteria for the buildings were raised as a result of it. Not as high as I suggested, but at least they were raised. Okay, so then the goal was, again, we're part of a collaboration. We had 2 questions that we needed to answer, but when we answer those questions well, we hand those answers off to the hydrologist, and then they model the flooding for the region. And so they use a flood level model called DFlow. I really don't know anything about it, other than they're really smart people and they tell me it's the best solution. And so basically it's layers of information. And so one of the layers will be our estimate of rainfall. Putting that all together, so here's the 1970. So this is one watershed. Rice University sits right here. So this was the 100-year floodplain in 1970. The dark blue is the color in 2011. So that's the 2011 floodplain. And the orange is the projected for 2040. But I say that the orange isn't quite right because what's not incorporated here is our improved estimate of ground cover. So that's one thing that we're working on right now. So this is based on 2005 ground cover maps, and they're just not correct. Just reiterate, there's where I work. So we are going to flood. Okay, so the takeaways.
Okay, so we have a dramatic increase in developed land. We have trends in return levels for some gauges, for most gauges. There are a few gauges where it actually goes down, but they're the anomalies. It's important that rainfall is modeled accurately within watersheds, so that's a driving piece for the flood maps. And our estimates provide input for flood models, and the output are predictions for Houston's future. So, data science in action. Houston is being rebuilt. We have no choice. We cannot afford not to rebuild Houston. We have to redesign the city. No one believes that we will never see another Harvey. Because it was 3 floods in a row. 3 years in a row we flooded. Harvey was the worst, but the 2 before that weren't so nominal either. Okay, so why was this influential? Because I was able to collaborate with the key decision influencers. I don't influence them, but my collaborators are in that conversation. I answered the questions that were asked. I didn't answer the questions that I wanted to answer. I answered the questions that they needed answered, and I answered them on time. If I answer them a year from now, they're not useful. They had to be answered last fall. Now, I will refine them before I publish on them, but the answers that we did get were informative. And so we also have improved estimates of land cover and rainfall return levels leads to improved floodplain modeling. This data science in action part 2. So the Kinder Urban Data Platform, again, kinderudp.org. It's a permanent archive for Harvey-related data. It's actually a permanent archive for all data about the Houston area. It's a 15-county area. And it's the opportunity to study and mitigate the long-term impact of Harvey. No one believes that it's just a week-long event. This is something that our community will be dealing with for the next 20 years. And so the Hurricane Harvey Registry provides regional health departments critical insight. And so this is in collaboration with them. So why could we have an impact? First and foremost is the willingness to engage. I could have sat in my office and continued doing what I do. I'm not an expert in extreme value analysis, so it took a little ramp up. I could have said, go ask this person who is an expert, but they're not part of the collaboration team. And so that too takes a time to figure out, right? So I had to be willing to step up and give this a go. And the important piece was building on the strength of long-term collaborations. So throughout my career, I've worked with scientists and city officials in Houston to help it in ways that fit with my talents. And we did have enough effort already underway and in the right direction. The Urban Data Platform, the land cover, that was done pre-Harvey. And then most importantly was the university support. It wasn't that much money, but it was important money. And it was sort of the recognition that engagement was important. That if I spend my time in this way, that it's valued by those who pay my salary. Okay? And that recognition was probably more important than the money, although I couldn't have hired a graduate student without the resources. So the strength of statistics and data science research and resources. So everything I did capitalized on what our community brings forward. So the message is what we do really, really does matter. So we should feel really good about it. and I'm in agreement that it's one of the best jobs to have in the world. And since I've trashed Houston so badly, let me remind you how beautiful it is and just say thank you. Okay?
Thank you, Katherine, for such an enlightening and great talk. So we can now open the floor for discussion. Please raise your hand. If you don't feel comfortable to ask in English, you can ask in Portuguese. I can try to translate or try to let Kathy to guess.
That would be a fun.
I have a question to start. So I know that the American Statistical Association has been doing a great job in promoting statistics in this new era of data science. what kind of advice would you give to Brazil and to other countries, especially Latin America, to pursue this kind of trend?
So I do think that I've been part of the data science conversation at many different levels, at the Rice level, at the national level, beyond the American Statistical Association, and very heavily involved with ASA. And the message in each case is just embrace what's coming, and these collaborations are so important. So as statisticians, we're rethinking how we train our PhD students so they are able to collaborate a little bit more strongly on big data science projects. The project I talked about, might get missed by someone who wasn't trained in statistics, because I don't know that someone who studies databases and algorithms could instantly understand generalized Pareto distributions. So there's value in how everyone is trained. And what we need to be able to do is to collaborate on those big problems. But to collaborate, we have to have enough of the other person's knowledge base so we know where they're coming from. Is that fair?
Are there any questions or comments?
Okay, mine is more a curiosity. You mentioned at the beginning of your talk about the march in Facebook, the professor march and behavior Facebook. I think that's a big issue in our society today, that we want one thing, but the government and the politician, they take to another way. So that's a problem. Biology, mathematical biology. I saw the same problem in our area, so you do not do what's important. You do what they pay us to do. So just some lines to mention about data science and so on.
I can commiserate. so we all have to get a paycheck, right? So we all are driven. One of my very, very, very best PhD students is a manager of data science infrastructure at Facebook. Right? She's brilliant. So I see all this talent going to Google and Facebook and Microsoft, and then I have JP Morgan coming and saying they can't get the talent because they're losing them all to Google, Apple, Facebook. But I think the bottom line is that there's just so much to do, and I do hope that I do think that our funding agencies, like for us, the major two are National Science Foundation and NIH, that they do recognize the importance of data science and statistics in the core science activities. But there have to be enough of us that are willing to continue to engage in science and not just in, Facebook isn't for everybody, right? So there, if we're, if the community is working well, then there will be that talent for the sciences as well, and I do think we're seeing that, but it's just, I think it was a good note to put up because it causes me pause, right? When I read it, I think, oh wow, are we doing the best for society and humanity with how we're choosing to spend our talents? But those are kind of big picture issues, and we're going to spend our talents with who paid our check, because unless we become independently wealthy. But I do think there are enough of us, and there will be enough jobs. This dark matter physicist, he needs an expert in data science working beside him. And I just hope that someone recognizes that, and that would create a job for someone that could do that. But I work on a lot of different areas, and because at Rice, we're a private institution, which translates to all of my research has to be funded by somebody else. So I have to go where the money goes, right? So that's one of the reasons that I work on many different areas. But we do try to focus on areas that make a difference. I do think that the brain imaging, the neuroscience and the evolution in cancer, those are data science driven. And our community has really helped significantly there. I would put that more on colonies on Mars, closer to colonies on Mars than I would Facebook, right?
I don't know if I answered the question. You may have an answer that's better than mine.
Is there any other question?
Thank you for your great presentation. I have two questions actually. The first question is about your project. I would like to know what was the size of your team and how did you manage to operate with them, to work with so many people? And the second question is, I would like a suggestion to we Brazilians. In Brazil, we have in some institutes, not all of them, but in some institutes we have difficulties to connect with computer science institutes. So sometimes we don't talk with them, and they don't talk with us. So with your experience, what should we do to create this bridge?
Bridge that gap.
Yes.
Okay, so I, again, I'm in the same building with computer scientists, electrical engineers, and applied mathematicians, and sometimes we don't talk to each other. So there's no universal answer, but I do think the conference of the new Statistics and Data Science Conference, so that has computer scientists at it. So that's a statistics conference with computer scientists. The NIPS conference has a good mixture between statisticians and computer scientists and electrical engineers. So there's key conferences that sort of are more machine learning like where we are interfacing. But I think the bottom line is just to keep knocking on the door and then inviting others into your space. You pick a few key collaborators. You know, I don't collaborate with 100 people. I collaborate with 20 people. But they're 20 really good people that do different things. And I've built that over a lifetime. You know, at the beginning, I was having a little bit of trouble doing what I wanted to do. And a really famous statistician that worked at the edge of computer science and statistics, he was with Bell Labs. He said, you just pick a different collaborator. Just move on. You know, if they're not getting your message, move to someone that will, because there's so many great problems and so many great people. And I think that's it. You know, you can pick good collaborators and then just keep going after it. You know, in the U.S., so much of the direction of our science is directed by the National Science Foundation. And they just haven't funded statistics like they funded computer science. And so what we see are statisticians that are knocking on the computer science funding door and winning. And so we need to do more of that. And we need more statisticians that are funded through the computer science directorate. And that will naturally bridge. But I think, you know, I don't know, in Brazil, I don't know where the points of friction are. But
maybe both of them, I don't have a quick answer, I think, but maybe both of them think that the work of the other is not so relevant. So maybe some statisticians think that the work of computer science in machine learning and such things is not so relevant because we know inference, we know such things. And the computer scientists, some of them think that all we do is just defining models and not solving problems.
No, it's a challenge, but I think I know a lot of great computer scientists that look for statisticians to collaborate with. And so that's probably the community to more focus on. Certainly as a young person, the first thing you have to do is establish your reputation. The easiest path to do that is what you want to do. You know, like what I've just talked about here, I could not have done as an assistant professor. I can only do this because I'm a full professor, and frankly, I have nothing to lose. You know, I have a profession, right? So I guess I could get fired for some reasons, but it's doubtful. Those reasons I can't imagine, but so I have a lot of flexibility in how I choose to spend my time. But as an assistant professor, you have to stay kind of focused and build up your reputation, or as a young person. But the NIPS conference is a great place for young statisticians to interface with leading computer scientists, sort of in the machine learning area.
Like the point to the question of him regarding the partnership. I believe, I don't know about USA, I haven't been in USA, but I spent my PhD in Master Science in Europe. In Europe, in my opinion, it's much easier for you to make partnership from different backgrounds than here in Brazil. I don't know about USA, but I think here we have a big resistance for people to, he mentioned the example of computer scientists. I had the same problem. Sometimes they don't want to talk to us, they do not feel comfortable to leave the box. So I think it's a cultural problem, in my opinion.
I go to a lot of computer science talks that have nothing to do with statistics, and I don't do that because I'm centrally interested in what they do. I do it so that I can understand where they're coming from. And, you can't do too much of that, but again, you don't try to connect with the whole field. You try to connect with a few good people in the field, and that's where you can bridge. And I think so that translation is local is best. Local being, it doesn't have to be someone in Brazil. It could be someone, in Europe or in the U.S. But it's that core partner from a different discipline, so that you can build up that partnership and really make great inroads. I don't know. I think that's worked for people time and time. And this isn't the first time in history that disciplines have faced this, right? So it's actually pretty common. But the languages are different, right? So, computer scientists think about data matrices. We think about random variables. So that's a very different way of approaching data.
Thank you so much for your talk. My name is Daniela, and I'm a professor from the Computer Science Department. I found this conference a great place to talk and to welcome every statistician that want to talk with us in our research group. That we can help you, so please you can contact us. I have only one question. Is to know about what do you think about is the next wave putting together machine learning and statistical and data science and all these buzzwords that is starting and is working with around our research area. So what do you think is going to be the next wave, the next trend that we can focus on researching or on thinking about researching?
Yeah, so big picture wise, I do think that quantum computing is going to catch us all off guard because we're just not ready for it, and it's going to change the way science is done. And so, and I don't know how to, from a statistics or computer science perspective, I don't really know how to bridge that conversation, but I do think it's big. I think we're going to be all facing just rapid new technologies, and then how does that translate into the models and the data that we're trying to perform our data science on. So one of my PhD students has a hugely successful blockchain startup, and I'm just sitting there in awe of what's going on, just watching it. And that's definitely a statistics, computer science collaboration for what they're trying to do. But leaving cryptocurrency aside, which I'm not a big fan of, don't think it's going to go away, but blockchain itself is a translational technology, and so how will that, if we're bringing all our medical records into that area. So I think as data scientists, statisticians, and computer scientists, some of us need to remain nimble so that we can sort of define those early opportunities in these these fields, but it won't be me, right? But I can see sort of the conversations that as technology evolves, then the types of data that we get evolve, and so we need to be ready to work with it. Does that answer your question? Okay.
So I think if there are more questions or discussions, Kathy will be happy to talk with every one of you in the coffee break. So let's thank Kathy again. Now we are going to have a coffee break right here, and at 4 sharp, we'll start here in the other building for parallel sessions.
Humans in is huge, right?